Boom. Let's keep that up today, so that way, whoever's watching, they can know exactly what we're working on. No confusions. Okay. So I'm going to go and throw up our first 20 minutes.
It's time to do.
There we go. Let's see now the world is all better. Yes, yes, glossy as you know what. All right, let's get to it. So I'm gonna start off with reading through this documentation. Actually, no, before I even read through the document, well, no, it'll be there. So we're gonna read through this documentation. We're gonna find out what exactly is the Kubernetes deployment YAML file. And as it says, we're going to learn by example. So the caveat though is we're not going to do their example. We're going to use our Urban Dictionary of Economic Data to deploy via the YAML file. And what we're also going to do, because we have like, let me show you this real quick. I'll show you this real quick. Looking through the course, right? Right here. And remind me later. So it has understanding rollouts. We figured that out on our own, right? It has understanding Google Cloud regions and zones. We did that on our own. I haven't gone through the master nodes and nodes yet, but that'll probably be like a Wednesday concept and overview type thing. But a lot of these things, we ended up figuring it out on our own, right? So when we look at, let me see, where was it? So quick introduction to microservices, right? Deploy microservices, Docker containers to Kubernetes. We ended up having to do that because what the application is, it is a microservice. So we ended up having to do that on our own, you know? So the course actually has to catch up to where we're at, you know what I mean? But it's all good. It is all good. But with that being said, let's go ahead and let's take a look at this. Let me see if I can zoom in a bit on this. That's whatever. Let's go to, why is it cut off like this? Let me zoom in some more. See. All right, I think that's good. All right, so what is Kubernetes deployment YAML, right? So YAML, which stands for YAML ain't markup language, well, that's interesting, is a language used to provide configuration for software and is the main type of input for Kubernetes configurations. It is human readable and can be authored in any text editor. So I'll say this, when I was working at, so my real software, like when I was working for a software development company, because the company I was working at before that one, it was kind of software development. They developed software, but I worked on the, I was not working testing software development, all right? I was testing the output of the application. But when I started working for a company that I was on the team of actually building software, they were using YAML files, and I didn't understand it too well, but I was able to navigate to it. I knew how to change the configuration and stuff like that. So the YAML file, it's pretty much the configuration of the software. Okay. And let me see what other, when we work on our Docker compose file, that is a YAML file that we are configuring to, and I think reading through this is going to put things in a lot better perspective for me. Okay. But it says a Kubernetes user or administrator specifies data in a YAML file, typically to define a Kubernetes object. The YAML configuration is called a manifest, and when it is applied to a Kubernetes cluster, Kubernetes creates an object based on the configuration. A Kubernetes deployment YAML specifies the configuration for a deployment object. This is a Kubernetes object that can create and update a set of identical pods. Each pod runs specific containers, which are defined in the spec.template field of the YAML configuration. The deployment object not only creates the pod, but also ensures the correct number of pods is always running in the cluster, handles scalability, and takes care of updates to the pods on an ongoing basis. All of these activities can be configured through fields in the deployment YAML. Below, we'll show several examples that will walk you through the most common options in Kubernetes deployment YAML manifest. All right, so that's pretty much what we're gonna do today. And I mean, we're gonna like we're going, like I said, we're going to apply it to our own stuff. Okay. Let me go ahead and the project I'm going to use, I'm going to use WebStorm for our IDE, but I'm going to use our infrastructure project. That's the one that I use to do Terraform, scale it up and scale it down. We're going to use that in order to, house our configuration. In theory, yeah, we're gonna use that because technically, like you could have the Kubernetes file as part of the actual project application. But the reason that I'm doing it in a separate project is because I want to be able to have one YAML file to spin up the whole application, right? So creating the front end, the back end, all of that. I just want it in one spot. All right. So let's take a look at this example real quick. And it says the following YAML configuration creates a deployment object that runs 5 replicas of an Nginx container. So let's read it through real quick, right? So API version apps v1. Let me go do this over here. All right, cool, perfect. So it says, all right, so application API version apps v1, and this is the API version for Kubernetes. The kind is going to be a deployment. Metadata, the name is going to be Nginx deployment. Labels, app is web. Okay, so because I'm not 100% sure what this metadata name is yet, but we'll find it. So spec, selector, match labels, app, web, replicas, stage, strategy, type, rolling update, template, metadata. So okay, spec, container, name is Nginx, image is Nginx. So giving the container a name. So the container port is going to be the port 80. Container port is port 80, and this is the part I always get a little tripped up on. So container port, so maybe that's going to be, all right, so port 80, so maybe that would be the port to access the application, right? So we'll double check on that. Important points in this configuration: spec.replica specify how many pods to run. Strategy.type specifies which deployment strategy should be used. Okay, so it's telling us all the details, right? So this is what I'm interested in. Spec.template.spec.container specifies which container image to run in each of the pods and ports to expose. All right, so that would be, so this spec right here, and then template, then spec, then container, and then the image and the port to run on. So I mean, this is like, it's kind of like how when we're doing our Docker, it falls into place. Let's see. So strategy. All right. So we see that. All right. Example 2 with resource limits. The following YAML configuration creates a deployment object with similar to the above, but with resource limits. Okay. So this is where they're specifying how much memory, how much CPU. All right. And the spec, all right, there goes the limits. Each container should not be allowed to consume more than 200 MI of memory. Request, each container requires 100 Ms of CPU resources and 200 MIs of memory on the node. And then with health checks as well, that would be, all right, so I don't think we have any health checks set up in our application yet, but that's fine. So we'll skip over that for now. The template.spec liveness probe field defines what the kubelet should check to ensure that the pod is alive. I mean, we could easily do on the path of the port that we're looking for and say that that it's up. All right. So that's, so as long as you don't get like a 400, if you get a 200 response, you should be good to go. HTTP GET specifies the kubelet should try an HTTP request on the root of the web server on port 80. And it's good to have the health check. So maybe I'll set up the health check. All right. Specifies how long the kubelet should wait after the pod starts before performing the first probe. How often the kubelet should perform a liveness probe. Let's see. And then example 4 with persistent volumes. The following YAML configuration creates a deployment object that creates containers that request a persistent volume using the persistent volume claim and mount it on a path within the container. All right. Okay, cool. With affinity settings. I'm not going to read into the volumes yet. Affinity, what are affinity settings? The following YAML configuration creates a deployment object with affinity criteria that can encourage your pod to schedule on certain types of nodes. Okay. Let's see. All right, I'm not going to read into that affinity thing yet because that's not important to what we're working on. Alternatives to the deployment object. Two common alternatives are daemon set deploys a pod on all clustered nodes or a certain subset of nodes. We're not even going to be concerned with that for now. I'm going to skip over this example because I just want to get to it. Let's see. Important fields of configuration are. Let's see. The important fields of this. All right, so that's cool. Stateful set. We're going to skip over that as well. Let's see. All right. Kubernetes deployment with CodeFresh. We're not going to be using CodeFresh. All right, so here is where we're going to get started. We're going to get started with, I'm going to do, because I actually like this health check. We're going to do it on the health check. We're going to do the one with the health check, all right? Because health checks are important to make sure that your application is up and running. So let's go to this one, right? We're gonna follow this model. And let me see, how should I do this? Let's go. Let me make sure the application is WebStorm is open, and we're gonna move that over here. All right, cool. So let's go ahead and let's move this. We're gonna switch screens over here. And why do I have this background up? Hold on. Let me change my backgrounds. That is for our economics show, not for when we are working on code. Let's go to... Let's go with that. I haven't used this one in a while. Let me see how this looks. Yeah, I haven't used that in a while. Let's do this one for today. Let's do this one for today. All right. So let's go ahead and let's go to here. All right. So what I'm going to do, so this is our Terraform folder. I'm going to create another folder for Kubernetes. And I am going to say a new file. And I'm going to call it deployment dot YAML. All right. And I think, okay, the best way to do this, let's close that. Let's move this over here. And I'm going to just bring this CodeFresh over here. And we will do I have rectangles running? Yes, I do. Let's go to, so let's do it like that, right? Let me make it a little bigger. And so this is a pretty cool app called Rectangles that if you have a Mac, where it can help organize your, your layout, especially if you have a lot of windows open like I normally do. It can help you with that, right? So that's a pretty cool app, Rectangles. I use that to help me stay organized. So now we have our deployment.yaml created. Let me make sure you can see it okay. Yep, there we go. We are. All right, we're good. So deployment.yaml, and I am going to start off with saying API version. And like when I'm creating something new for the first time, I like to actually write it out instead of just copy and paste, because that way it's going to help me stick a little bit better. Say kind, and we're going to say deployment. And we're going to say metadata. We're going to say name, and we're going to call that UDEC-BE for the front end. We're going to say labels, and that's going to be app, and then I'll call it backend, I guess, for the label, or I don't know, UDEC. I'm not sure what the label is for, but it's okay. And then so spec gets, let me make sure. Yep, spec is on its own level, so spec, colon, and we're gonna say selector, Ah, okay. I see what the label is being used for. Um, I do have a question though. I wonder if on if you're using the auto cluster. So let's go back over here for a second. Just thinking it out real quick, right? Get some water. So just thinking out first. I'm thinking out loud for a second, right? If you are using the YAML Kubernetes file with GKE auto cluster. I forgot cluster. I forgot the exact name of it, right? But let's see. Cause I'm just curious. I thought I switched over. Hold on. Let me switch over. I'm just thinking. I'm just thinking about how is the. Let me see. Because when you create a cluster with Google Cloud, GKE cluster, deploy an app to a cluster. Sorry, let's take a look at this real quick, right? So when we create our cluster, create auto. So when you do a create auto, do you have to specify replica when, oh, okay, for GKE cluster? Let's take a look at that one. No, you don't always have to specify replicas for GKE cluster, but you do need to specify them when deploying applications using Kubernetes deployments or replica sets, as these define how many pods replicas your application should run. Okay. Because we don't specify them when we're doing it, but maybe if we're doing the deployment file. So let's give it a try. Like I said, we are figuring it out. We're learning, so we can always try taking it out afterwards and applying it. So we shall see, right? So selector, match labels. So by matching the labels, it looks like what it's going to do is saying match this. So I'm just going to call this B instead, right? Match this with this. So this is going to be UDEC-BE. And then we're going to say replicas, and we'll go with 3 for now. And we'll say the strategy is going to be rolling update. And we will go with, this is going to be type over here. And then we're going to say template, metadata, labels, app, and it's going to be UDEC-BE. And then outside of on the metadata level, we're going to say spec, and we're going to say containers, which is going to be our UDEC-BE, which is going to be, now we're going to say image, which we're going to be specifying our tech coach Ralph / UDEC-BE colon AMD64, because remember that is I think there's two dashes over here. No, because that is, we need to run AMD64 on the Google Kubernetes cluster because of the platform differences. All right, so why is this giving me an error? Let's see. Replace with invalid child element in block mapping. What? Let me just copy this right here to see, make sure what type of hyphen that they're using. It's just one. Okay. Let me see one more indent. Let's see what this is. Why is this not working? Let me copy this whole thing to see what happens with it. Huh. Okay, well, whatever. Let's leave it at that for now. We're going to go to the next line, and I'm not going to put in the I'm not. Are we looking at? All right. So this is the one that we actually want to be looking at. So we're not going to put in the resources. We're going to say the port colon, and then I don't know. I don't like this. Let me go with this one right here. I'm going to say the ports is going to be
lunch break.
Container port, and we're going to say port container port. That should be port 3000 because that's where it's trying to access. And then we will go back one level and we'll say liveness. Let's just finish typing this out. Liveness probe, HTTP get, and we're gonna say the path. I don't know. I'm gonna hold off on this part for now. All right. So let's leave it at that. And we shall. Let's leave it at that. I think the first. Let's do it. Let's go with the first one. Right. Let's leave it at that. We have our container port. I'm curious. The container. What is the container port? The container port is. Let's do this. Container port Kubernetes deployment. That would be what? I always get confused on this one, right? The container port specifies the port on which a container within a pod listens for incoming traffic, acting as an informational value for the application network. All right, we'll put it at 3000 for now, right? We'll put it at 3000 for now. Let's go over to break, and then when we come back, we'll try to apply this and we'll see what happens, okay? But let's go to break. Let me see what we got going on in the chat, and then I will get to my first break time discussion. Have some thoughts to share.
Scrolling through my phone, I can find a spark. Each day feels like a bug in a broken arc. But my lines of code know me better than they do. In love with these scripts, they hold me true. Conversations fizzle, hearts feel like a chore. Bad dates come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding my pain. Dining on hopes, but the vibe feels so wrong. Wondering if I can fix what's taking too long. But while dinner gets cold, my thoughts start to race. I'd rather be debugging in my own safe space. Is it me or the code that keeps me awake? Bad days come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding my pain. Okay. Dining on hopes, but the vibe feels so wrong. Wondering if I can fix what's taking too long. But while dinner gets cold, my thoughts start to race. I'd rather be debugging in my own safe space. Is it me or the code that keeps me awake? Awake. Bad dates come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding